You are sitting in a room whose dimensions you understand without effort. The walls are a fixed distance apart. Your body occupies a precise volume. When you look up at the night sky, you assume that what you see is arranged in a similar way. Objects separated by space, placed next to one another, forming recognizable shapes. The Virgo constellation appears to confirm this assumption. It looks like a region, a patch of sky, a bounded area you could, in principle, point to and outline. But every distance measurement ever taken of the stars and galaxies labeled Virgo contradicts that picture. Objects assigned to the same constellation are not neighbors. They are not even close. Some are tens of light years away. Others are tens of millions. Some are gravitationally related. Others are not connected at all. The only thing they share is a direction. From where you are standing, they overlap. The question is not why Virgo looks large. The question is what it even means to ask how big it is. The shape you think you see. You begin with the assumption that a constellation is an object. Virgo looks like an extended shape drawn across the sky, and your visual system treats it as a single figure. Observation contradicts this immediately. The stars that define Virgo do not occupy a shared region of space. They only align along your line of sight. The shape exists in projection, not in three-dimensional reality. This assumption is not careless. It is functional. On Earth, shapes correspond to objects because depth is usually small compared to width. A tree, a building, a mountain range all occupy a compact volume. Your brain is optimized for this environment. When points of light arrange themselves into a pattern, you interpret them as parts of the same thing. The night sky invites this interpretation because it removes distance cues while preserving angular position. Measurement removes that convenience. The stars that outline Virgo sit at radically different distances from you. Some are within your local region of the Milky Way. Others lie far beyond it. Their apparent proximity is an artifact of alignment, not adjacency. If you could move sideways through space, the shape would dissolve almost immediately. Lines would stretch. Angles would collapse. The figure would not survive even a small change in viewpoint. This is not a limitation of early astronomy. Modern measurements confirm it with precision. Stellar parallax reveals that the foreground stars of Virgo are separated by dozens or hundreds of light years from one another. Spectroscopic analysis shows that they are not moving together. They do not share origin, age, or trajectory. Nothing binds them except the fact that you are looking from here. The contradiction deepens because your perception does not adjust when the distances are revealed. Even after you know that these stars are unrelated, the shape remains stable in your vision. Knowledge does not overwrite geometry. You continue to see Virgo as a coherent figure because your sensory system has no mechanism for displaying depth at astronomical scales. This is where the idea of size begins to fracture. If Virgo is a shape without depth, its size seems small, defined by a region of sky measured in degrees. If Virgo is a collection of stars in space, its size becomes undefined because there is no single distance at which it exists. The question of how big it is cannot be answered without first deciding which interpretation you are using. Astronomy does not resolve this by choosing one. It holds both simultaneously. Catalogs assign stars to Virgo based on position alone, while distance data quietly undermines the implication that those stars form a unit. The constellation persists as a reference system even after its physical meaning evaporates. This creates a subtle distortion in how you think about space. You are trained to believe that labels correspond to regions. Virgo appears to be a region, but measurement shows that it is not a region in any physical sense. It is a direction, a slice through space extending outward from your position, intersecting unrelated structures at different depths. The implication is not philosophical. It is practical. When you say an object is in Virgo, you are not describing where it is. You are describing where you must look to see it. The sky becomes a map of directions rather than places. Distance is deferred to data tables, removed from the act of seeing. This separation between sight and structure is not resolved as you learn more. It intensifies. Each new distance measurement adds depth without changing appearance. Virgo grows not wider, but deeper, accumulating layers that cannot be visually distinguished. What you are left with is a shape that survives only because of your position. It exists as long as you do. Move far enough away, and it disappears. Not because the stars vanish, but because the alignment that created the shape no longer holds. The object you thought you were seeing was never there. It was a coincidence enforced by perspective, direction without distance. When astronomers catalog Virgo, they do not group its contents by proximity. They group them by angle. Two objects can be placed in Virgo while being separated by millions of light years along the depth you cannot see. Measurement shows that direction is preserved, but distance is ignored. This is the first distortion. This method is not arbitrary. From Earth, angular position is the most immediate and reliable information available. You can measure where something appears in the sky with extreme precision, long before you can measure how far away it is. Direction arrives first. Distance comes later, if at all. Constellations are built from this ordering of knowledge, not from physical structure. The distortion emerges because angular grouping feels like spatial grouping. When two objects occupy the same direction, you instinctively assume they occupy the same region. In everyday experience, this assumption is usually correct. In astronomy, it fails systematically. The sky preserves angles while hiding depth, and your perception fills in the missing dimension incorrectly. Distance measurements expose the scale of this failure. A nearby star assigned to Virgo might lie within a few hundred light years. A galaxy labeled Virgo might lie tens of millions of light years away. Between them stretches a volume of space larger than your intuition can comfortably represent. Yet observationally, they are neighbors. They share coordinates on a two-dimensional sphere centered on you. This sphere is an abstraction, but it governs nearly all visual astronomy. Everything you see is projected onto it, regardless of where it actually exists. The result is a catalog that mixes foreground and background without distinction unless additional data is consulted. Virgo becomes a stack of unrelated objects compressed into the same angular container. The consequences are subtle. When you hear that something is in Virgo, the statement carries no information about scale. It does not tell you whether the object is inside your galaxy or far beyond it. The label replaces physical relationship with directional coincidence. Space becomes sorted by where you look, not by what is near. This inversion is rarely confronted because it is operationally useful. Telescopes are pointed by angle. Surveys sweep regions of sky, not volumes of space. The universe is first divided by direction, because that is how instruments interact with it. Distance is reconstructed afterward, object by object, never globally. As more distances are measured, the internal inconsistency grows. Objects that share a label diverge in every other measurable property. Their motions differ. Their histories do not intersect. Their gravitational environments are unrelated. The only invariant is their apparent position relative to you. This forces a reevaluation of what a region of the sky represents. Virgo is not a place where things are. It is a set of lines extending outward, each line intersecting matter at different points. To speak of its size is to ask how long those lines should be drawn before they no longer count. There is no physical rule for where to stop. You can always look deeper along the same angle. New objects will appear farther away, older in the light they emit. Each one can be assigned to Virgo without violating any observational constraint. The constellation expands indefinitely, not across the sky, but through it. This is the distortion that persists even in precise cosmology. Direction remains fixed. Distance fragments. Virgo is stable as a pattern, while unstable as a structure. Its apparent coherence survives only because depth is optional in how you see. The unsettling implication is that much of what you call location in astronomy is conditional. It depends on the observer and the coordinate system, not on physical connection. Virgo is not large or small in the usual sense. It is shallow in your perception and vast in measurement. And there is no single scale at which those descriptions reconcile. The nearest stars in Virgo. Some of the brightest stars labeled Virgo are relatively close by galactic standards, measured in tens or hundreds of light years. Parallax measurements confirm their positions with precision. These stars feel local. They reinforce the illusion that Virgo is nearby and coherent. But they represent only the foreground. Parallax is one of the few distance measurements that does not rely on assumptions about the universe. As Earth moves around the Sun, nearby stars appear to shift slightly against the background. The angle of that shift is small but measurable. From it, distance follows directly. When this method is applied to Virgo's brightest stars, the result is clear and unambiguous. These objects belong to your immediate galactic neighborhood. This matters because proximity changes how you interpret what you see. Nearby stars appear brighter, not because they are more powerful, but because they are closer. Their clarity gives them visual authority. They dominate the constellation's outline and anchor its shape. When you think of Virgo, these stars are what you picture, even though they are not representative of what occupies that direction in space. The contradiction is that these stars do not define Virgo in any physical sense. They are not central. They are not typical. They are simply close enough to be visible without assistance. Their presence at the front of the line creates the impression that the entire constellation exists at a similar distance, compressed into a shallow region of space. Measurement disrupts this compression without removing the visual effect. Knowing the distance to these stars does not cause the background to recede perceptually. The sky does not separate into layers when you understand parallax. Foreground and background remain visually merged, even as their physical separation becomes extreme. These nearby stars also move independently. Proper motion measurements show that they drift across the sky over time. Given enough centuries, the shape of Virgo will change as these stars slide out of alignment. The constellation is not stable even at its nearest layer. Its most familiar components are transient. This introduces a temporal dimension to the illusion. The Virgo you see now is not the Virgo seen in the past, and will not be the Virgo of the future. The stars that make it feel coherent are passing through your line of sight. They are not fixed markers of a structure. They are momentary participants in a pattern created by motion and perspective. Behind them, the background remains largely static on human timescales. Distant galaxies shift so slowly that their alignments appear permanent. The foreground stars, which feel solid and immediate, are the most unstable elements of the scene. What seems closest is what changes fastest. This inversion is easy to overlook. You are inclined to trust what appears bright and sharp. Yet those qualities indicate nearness, not relevance. The nearest stars in Virgo tell you almost nothing about the larger structures that dominate that direction. They mask depth by occupying your attention. The implication is that Virgo's apparent size is anchored to objects that are not central to its true scale. If you measure Virgo by its nearest stars, it is small, local, and shallow. If you measure it by what lies behind them, it expands dramatically. Both measurements are correct, and they describe different things. The foreground stars are not misleading because they are inaccurate. They are misleading because they are incomplete. They reveal one layer while concealing others. Virgo begins close, but it does not end there. The first distances you measure give you confidence. The later ones take that confidence apart. By the time you account for everything along the same direction, the nearest stars become a thin skin over something vastly larger. They are the part of Virgo that you can touch in cosmic terms. But they are not what Virgo is. They are simply where your measurements begin. The sudden appearance of galaxies. As instruments improve, Virgo begins to fill with galaxies. Not faint background noise, but structured systems. Redshift measurements reveal that many of these galaxies are not nearby at all. They are tens of millions of light years away, occupying a depth your eyes collapse into a surface. This transition is not gradual in perception. To the unaided eye, Virgo is sparse. With modest telescopes, smudges appear. With deeper surveys, those smudges resolve into disks, ellipses, and clusters. The sky is not signal when this change crosses a threshold. There is no visual cue that tells you when stars give way to galaxies. The same angular region simply accumulates structure. Redshift provides the separation that vision cannot. When light is stretched toward longer wavelengths, the amount of stretching corresponds to distance through cosmic expansion. Applied to Virgo's faint objects, this measurement shows that many are not members of the Milky Way at all. They exist far beyond its boundaries, at distances that dwarf the foreground stars by factors of hundreds of thousands. This introduces a new scale without changing the frame. The galaxies occupy the same patch of sky as the nearby stars, yet they belong to a different regime of the universe. Their light began traveling toward you before the nearest stars had completed even a small fraction of their galactic orbits. You observe them together as if they were contemporaries. The contradiction is that galaxies are not subtle additions. Each one is a system of billions of stars, gas, dust, and dark matter. Their physical size alone exceeds the entire distance between many of the stars that define Virgo's outline. Yet they appear as points or faint blurs, visually subordinate to single nearby suns. This reversal is enforced by distance. A galaxy can outweigh a star by orders of magnitude and still lose visual prominence if it lies far enough away. Virgo becomes a place where the most massive objects are the least conspicuous. Scale and visibility diverge completely. As more galaxies are cataloged, the depth of Virgo expands dramatically. The constellation acquires a background that is not background at all, but an extended structure. The sky's flatness becomes increasingly misleading. What you are seeing is not a surface sprinkled with objects, but a cross-section through a volume tens of millions of light years thick. There is no natural boundary where this process stops. Each increase in sensitivity reveals galaxies that are fainter and farther. All of them can be placed within Virgo as long as they align with its angular borders. The constellation grows not because anything moves, but because your instruments reach deeper. This creates a conceptual instability. Virgo now contains objects that cannot influence one another in any meaningful way. They do not share environment or history. Some are gravitationally bound to each other. Others are separated by expanding space. The name applies equally to all of them, despite these differences. Time complicates the picture further. The galaxies you see are not as they are now. Their light is old. You are stacking different cosmic eras into the same visual field. Virgo becomes not just spatially layered, but temporally stratified. Near stars are seen almost in real time. Distant galaxies are seen as they were tens of millions of years ago. This layering does not announce itself. The sky offers no indication that you are looking across time. The galaxies do not appear aged or distant in any intuitive way. Only measurement reveals the temporal depth hidden behind the apparent surface. The unsettling implication is that Virgo's size increases every time you learn more about it. What began as a local pattern of stars becomes a corridor through deep space. The constellation's boundaries remain fixed on the sky, while its contents recede indefinitely. By the time galaxies enter the picture, Virgo can no longer be thought of as nearby or unified. It becomes a direction through which you observe vastly different scales of reality at once. The appearance of galaxies does not add detail to Virgo. It removes the last justification for thinking of it as a single place at all. The Virgo cluster emerges. At roughly 65 million light-years, a concentration appears. The Virgo cluster is not a visual pattern, but a gravitational one. Hundreds to thousands of galaxies are bound together. This cluster occupies the same direction as the Virgo constellation, but not the same space as its stars. You do not see the Virgo cluster by shape alone. Its presence is inferred from density and motion. Galaxies in this region are closer together than average, and their velocities deviate from what cosmic expansion alone would produce. They move as if responding to a shared gravitational center. This behavior marks the boundary of a structure that cannot be outlined by eye. Unlike the stars that define Virgo's outline, the galaxies of the Virgo cluster are physically related. They interact, merge, and fall toward common mass concentrations. Their arrangement is three-dimensional and extended. The cluster spans several million light-years across, a scale that overwhelms the distances between the foreground stars that visually dominate the constellation. This introduces a second contradiction. The most physically real structure associated with Virgo is not the one you notice first. It does not define the constellation's shape. It does not anchor its outline. It sits far behind it, invisible without systematic measurement. What feels central is peripheral. What is peripheral is massive. The cluster's discovery did not come from imaging alone. It required redshift surveys and statistical analysis. When astronomers plotted galaxy distances in the Virgo direction, a peak appeared. Many galaxies were clustered around the same distance. This was not a coincidence of alignment. It was a region of space with genuine cohesion. Once identified, The cluster redefines the scale of Virgo. The constellation can no longer be thought of as a shallow arrangement of nearby stars. It now points toward a structure millions of light years wide, containing more stars than exist in your entire galaxy. The foreground stars become incidental, no longer representative of the dominant mass in that direction. The Virgo cluster also behaves differently from its surroundings. Galaxies within it are often stripped of gas, distorted by tidal forces, or altered by repeated interactions. These processes leave observable signatures. The cluster is active, dynamic, and internally complex. None of this is apparent from its position in the sky. From your perspective, the cluster and the stars occupy the same coordinates. They overlap perfectly, yet one is a local scattering of unrelated objects, and the other is a deep, gravitationally bound system. The sky presents them as equivalent. Measurement insists they are not. This equivalence creates a problem for the idea of size. If you ask how big Virgo is and include the cluster, the answer jumps abruptly. Virgo now spans millions of light years in depth and width. If you exclude it, Virgo collapses back into a nearby pattern with no physical unity. Both interpretations are supported by observation. Neither cancels the other. The cluster also introduces hierarchy. It is not just another layer behind the stars. It is a dominant feature of the local universe. The Milky Way itself is gravitationally influenced by structures associated with Virgo. Your galaxy's motion through space is partly shaped by mass concentrations in that direction. This means Virgo is not merely something you look at. It is something that affects where you are. The direction you label Virgo corresponds to a region of space whose gravity participates in defining your cosmic trajectory. The constellation's relevance extends beyond observation into dynamics. Yet this influence is not localized to the stars you recognize. It originates in galaxies you cannot see without instruments and could not intuitively associate with the shape you know. The name Virgo bridges entities that have no direct relationship except through your line of sight. The emergence of the Virgo cluster does not resolve the question of size. It destabilizes it further. Virgo is now simultaneously a nearby visual pattern and a distant gravitational system. The two coexist without merging. The constellation survives as a label, while the cluster asserts itself as a structure. They align, but they do not agree. From this point on, Virgo can no longer be described without ambiguity. Its most significant component is not where it appears to be. Its true scale is hidden behind familiarity. And the deeper you measure along that same direction, the less meaningful the original shape becomes. A cluster inside a constellation. The name suggests containment, but the relationship is reversed. The Virgo constellation does not contain the Virgo cluster physically. It merely points toward it. The cluster's diameter spans several million light years, dwarfing the stellar distances that define the constellation's outline. Containment is an intuitive concept. On Earth, when one thing is said to be inside another, their boundaries overlap in space. A city contains neighborhoods. A room contains objects. You apply this logic automatically to the sky. A cluster named after a constellation sounds like something enclosed by it. Measurement shows the opposite. The constellation has no depth. The cluster does. The Virgo cluster exists as a three-dimensional structure with measurable extent. Galaxies within it orbit common centers of mass, interact gravitationally, and evolve together. Its boundaries are not sharp, but they are real, defined by changes in density and motion. The cluster occupies a volume of space that would envelop the entire region, traced by Virgo's foreground stars many times over. By contrast, the constellation exists only as an angular framework. Its edges are lines drawn on the celestial sphere, not surfaces in space. They do not intersect with the cluster's boundaries. They do not enclose its volume. They simply align with it from your vantage point. The apparent nesting is an illusion created by naming. This reversal matters because it undermines the way you think about scale. The cluster is vastly larger than the distances between the stars that make Virgo recognizable. Some of those stars are separated by tens of light years. The cluster extends across millions. Yet the smaller structure gives its name to the larger one, as if the minor defined the major. The reason this persists is historical and observational. The constellation was named long before the cluster was known. When the cluster was discovered, it inherited the label of the direction in which it appeared. The name encodes perspective, not structure. It preserves the order in which you learned about the universe, not the way the universe is arranged. This creates a quiet inversion of importance. The stars that define Virgo's outline are visually prominent, but physically insignificant on large scales. The cluster is physically dominant, but visually anonymous. You can recognize Virgo without instruments. You cannot recognize the Virgo cluster without data. Even after learning this, the language does not change. You continue to speak as if the constellation is primary. The deeper structure remains secondary, described in relation to the pattern that happens to point toward it. This linguistic habit reinforces the illusion of containment, even as measurement contradicts it. The mismatch extends to boundaries. The cluster's influence does not stop at the edges of the constellation. Its gravitational reach extends beyond Virgo's angular borders into neighboring constellations. Galaxies that are part of the same physical system are labeled differently because they appear in different parts of the sky. Physical unity is split by visual convention. At the same time, Virgo contains stars that have nothing to do with the cluster at all. They are too close, too small, and too weakly connected to participate in its dynamics. They sit in front of it, unrelated, yet they share its name. The label binds what space keeps separate. This reveals a deeper issue with how you parse the universe. You inherit categories based on appearance, then retrofit them with physical meaning. When the meaning fails to align, you keep the category and tolerate the inconsistency. Virgo remains both a shape and a signpost, even though those roles conflict. Asking how big Virgo is becomes problematic in this context. If you measure the constellation, it has no depth. If you measure the cluster, it is immense. If you treat one as containing the other, you misrepresent both. The relationship cannot be made spatially coherent. What remains is a directional coincidence elevated to a conceptual framework. The constellation points. The cluster exists. The name connects them without describing their relationship accurately. Virgo is not a container. It is a pointer that happens to align with one of the largest nearby concentrations of matter in the universe. This is not an error that can be corrected with better maps. It is a consequence of observing from one place. As long as you stand here, looking outward, the largest structures will be named after the smallest patterns that happen to sit in front of them. The inversion will persist, quietly embedded in the way you talk about the sky. Scale without visual warning. Nothing in your perception signals this transition. The stars and the cluster overlap seamlessly in your field of view. Measurement alone reveals that one structure is millions of times deeper than the other. The sky does not warn you when scale changes by orders of magnitude. This absence of warning is not a flaw in observation. It is a geometric consequence of distance. When objects are far enough away, their physical size becomes irrelevant to how large they appear. A star 100 light-years away and a galaxy cluster 60 million light-years away can occupy the same angular footprint. Your eyes record only direction and relative brightness, not true extent. On Earth, scale is communicated by context. Nearby objects occlude distant ones. Perspective compresses background features. The sky removes these cues entirely. There is no atmospheric perspective in space, no vanishing point that signals depth. Everything is placed on the same visual plane, regardless of its actual distance from you. This flattening means that transitions in scale occur silently. You can move from individual stars to galaxies to clusters without any perceptual boundary. The same field of view accommodates all of them. The universe does not change appearance when its size changes. Only your measurements do. The contradiction is that your intuition expects scale to announce itself. Larger things should look larger. More distant things should feel farther away. In the sky, these expectations fail. Size and distance decouple. Massive structures shrink to insignificance, while small, nearby objects dominate the scene. This decoupling forces reliance on instruments. Spectroscopy, redshift surveys, and statistical mapping replace vision as the primary tools for understanding structure. Without them, you would never suspect that the Virgo cluster exists at all. The sky would remain a shallow arrangement of lights. Even with data, the transition remains conceptually unstable. You know that the cluster is there, but you cannot see it as a whole. You must imagine it, assembled from measurements taken object by object. Its size is not experienced directly. It is inferred. This inference has limits. The cluster does not present an edge you can point to. Its boundaries fade gradually into surrounding space. The moment you decide where it begins and ends depends on thresholds you choose. Density, velocity, and gravitational influence all suggest slightly different extents. Scale becomes a matter of definition. The same is true for the stars in front of it. Their grouping into a constellation is also a matter of convention. The transition from stars to cluster is therefore not just unmarked perceptually, but ambiguous conceptually. There is no single moment where Virgo stops being local and starts being cosmic. This ambiguity is rarely acknowledged because it does not interfere with routine observation. Telescopes still point, catalogs still function. But when you ask about size, the lack of visual warning becomes a problem. You are forced to confront the fact that your primary sense is unsuited to the question. The sky encourages a false continuity. It presents everything as equally accessible, equally present. The Virgo cluster feels no farther away than the stars in front of it, even though its light has traveled vastly longer to reach you. Time and distance are collapsed into the same moment of seeing. This collapse affects how you imagine causality. Events separated by millions of years appear simultaneous. Structures separated by millions of light years appear adjacent. The universe you perceive is compressed into a thin shell around your position, stripped of its true proportions. Measurement restores those proportions, but only abstractly. Numbers replace experience. You learn that one thing is 1,000,000 times farther than another, but nothing in your perception changes to match that knowledge. The dissonance remains unresolved. This is why the question of how big Virgo is feels unstable. The answer depends on which transition you acknowledge and which you ignore. Without visual warnings, you default to the smallest scale available. With measurement, you are forced to accept the largest. The sky does not guide you toward the correct scale. It offers no hint that you are crossing boundaries that matter. It allows you to mistake coincidence for structure and proximity for unity. Virgo appears continuous because your perception cannot represent the discontinuities that define it. The unsettling implication is that the universe can change scale beneath your gaze without you noticing. Entire orders of magnitude can pass silently. What you think you are seeing remains the same, even as what is actually there becomes something completely different. The supercluster. Beyond the Virgo cluster itself is not isolated. It is part of a larger arrangement of matter known as the Virgo supercluster. This structure extends over 100 million light years. Its boundaries are defined statistically, not visually. You cannot see its edges, only infer them from motion. The existence of the supercluster is revealed not by brightness, but by coherence. When astronomers measure the velocities of galaxies across a wide region of space, patterns emerge. Galaxies do not move randomly. Their motions show subtle correlations, slight deviations from uniform cosmic expansion. These deviations point to mass distributed across scales too large to be seen directly. This is how the Virgo supercluster is identified. It is not a solid object with a clear outline. It is a region where matter is more concentrated than average, where gravitational influence produces measurable effects. Its shape is irregular, its density uneven. It does not present itself as a form you can recognize. It must be reconstructed from data. This method of identification changes what it means to say that something exists. The supercluster is not an object you could photograph in isolation. Any image you take includes foreground and background that are not part of it. Membership is assigned based on motion and position in a multi-dimensional space of measurements. Visibility is secondary. The scale of the supercluster forces another revision of Virgo's size. The cluster you previously treated as large becomes a substructure. Its millions of light years are absorbed into a system an order of magnitude larger. The direction you call Virgo now corresponds to a region of space whose depth rivals a significant fraction of the observable universe's local volume. This expansion does not alter appearance. The same stars and galaxies remain in the same places on the sky. Nothing signals that the structure behind them has grown again. The supercluster does not add new visual features. It adds relationships. These relationships are dynamic. Galaxies within the supercluster fall toward common attractors over billions of years. Their trajectories bend. Their velocities shift. The supercluster is defined by these slow movements, not by any static arrangement. It exists through time as much as through space. This introduces another complication. The supercluster is not gravitationally bound in the way a cluster is. Cosmic expansion continues to stretch it. Some parts will eventually drift apart. Its coherence is partial and temporary, yet it is still real enough to influence motion now. The boundaries of such a structure are necessarily fuzzy. Different criteria produce different extents. You can define the supercluster by density, by velocity flow, or by connectivity to cosmic filaments. Each method yields a slightly different size. There is no single, definitive edge. This ambiguity feeds back into the question of how big Virgo is. If Virgo includes the supercluster, its size becomes statistical rather than geometric. It is no longer a region you can draw, but a region you calculate. Its existence depends on thresholds and models, not on sight. At this scale, the distinction between constellation and structure becomes even more strained. The name Virgo continues to apply because the direction remains the same. But the physical reality behind that direction now extends far beyond anything the original pattern of stars could suggest. The supercluster also dissolves the idea that Virgo is special or isolated. It is one concentration among many in a cosmic web. Filaments connect it to other superclusters. Voids surround it. The direction you label Virgo intersects this web at one node, but the web itself extends far beyond. From your position, this entire hierarchy collapses into a single visual field. Stars, clusters, and superclusters occupy the same patch of sky. The labels you use do not scale with the structures they reference. They persist unchanged as depth accumulates behind them. The unsettling implication is that there is no final scale at which Virgo resolves into a stable object. Each level of structure redefines the previous one as incomplete. What you thought was the background becomes foreground to something larger. Virgo does not end with the cluster. It does not end with the supercluster. It ends only where your measurements stop, and even then, only provisionally. The size of Virgo grows not because space expands, but because your understanding of what lies along that direction continues to deepen without ever becoming visually complete. Motion as a measuring tool. Galaxies in the Virgo region move in correlated ways. Their velocities deviate from pure cosmic expansion. These deviations allow astronomers to map mass that cannot be seen. The apparent size of Virgo grows again, this time defined by gravitational influence rather than light. In an expanding universe, distant galaxies should recede from you in a simple, predictable way. The farther away they are, the faster they should move. This relationship is measured precisely and holds across vast distances. But in the direction of Virgo, many galaxies do not follow it cleanly. Their motions contain excess components. They are being pulled. These deviations are small compared to the overall expansion, but they are consistent. When plotted across the sky, they form patterns. Galaxies stream toward certain regions rather than drifting uniformly outward. The only explanation compatible with observation is mass. Not mass you can see directly, but mass inferred from its gravitational effects. This changes how Virgo is measured. Light defines where objects appear. Motion defines how they interact. When you use velocity instead of brightness, Virgo stops being a visual corridor and becomes a dynamic system. Its boundaries shift again, now determined by how far its gravitational influence extends. This influence does not respect the limits of the Virgo cluster, or even the supercluster as previously defined. Galaxies well outside the dense core show motion that suggests they are still responding to the same mass concentration. They are not bound, but they are affected. Virgo expands outward into regions that look empty, but are not dynamically neutral. At this stage, Virgo is no longer identified by what you see, but by what moves differently because it exists. Mass asserts itself without revealing its form. Dark matter dominates these measurements. Most of the mass shaping these motions emits no light at all. Virgo grows larger as visibility becomes less relevant. This creates a second map of the same direction in space. One map is built from light and positions. The other is built from velocities and accelerations. They do not align perfectly. Some regions that appear sparse exert strong influence. Some regions that appear dense contribute less than expected. The structure you infer from motion is not the structure you infer from sight. From your perspective, this is deeply counterintuitive. You are accustomed to locating things by seeing them. In Virgo, what matters most cannot be seen. The region's true extent is revealed only through careful subtraction of what expansion should be, leaving behind what gravity demands. The method also introduces time explicitly. Velocity measurements capture change. They tell you not just where galaxies are, but how their positions are evolving. Virgo becomes a region defined by future trajectories as much as present locations. Galaxies moving toward the same attractor are grouped together, even if they are currently far apart. This redefinition stretches Virgo again. Its size now depends on how long gravitational influence has been acting and how long it will continue to act. Boundaries become predictions. Virgo includes regions whose connection exists in motion, not proximity. The unsettling part is that this influence reaches into areas that visually belong to other constellations. Motion ignores the sky's divisions. A galaxy labeled elsewhere can still be part of Virgo's gravitational domain. The name becomes increasingly detached from the physical reality it references. At this scale, Virgo is no longer something you can outline. It is something you calculate. Its size is not measured in degrees or even in light years alone, but in deviations from expectation. The question becomes not where Virgo is, but how strongly its mass alters the flow of space around you. This also places you inside the system you are measuring. The Milky Way itself has a peculiar velocity influenced by nearby mass concentrations, including those associated with Virgo. Your own motion through the universe is part of the data. Virgo is not just observed. It participates in defining your frame of reference. By using motion as a measuring tool, Virgo ceases to be a background feature of the sky. It becomes an active agent, shaping trajectories across a vast region. Its size grows again, not because more objects are added to it visually, but because its influence reaches farther than light alone would suggest. At this point, asking how big Virgo is no longer refers to how much space it occupies, but how far its presence is felt. The answer depends on gravity, not appearance, and it continues to expand as long as motion reveals connections that sight cannot. The sky as a flattening machine. Your position inside the universe forces 3 dimensions into 2. Virgo becomes a single patch despite containing structures separated by unimaginable distances. This flattening is not a trick. It is a geometric consequence of observation from a single point. Every observation you make originates from the same location. Light travels toward you along straight paths, arriving from different directions but converging at your eyes. By the time it reaches you, all information about where along that path it originated has been erased unless you reconstruct it through measurement. Direction survives. Depth does not. This is why the sky behaves like a surface. It is not that the universe is arranged on a sphere around you, but that all incoming information is projected onto one. Virgo appears as no deeper than any other constellation because depth is not encoded in appearance. Objects separated by millions of light years are mapped onto the same angular coordinates. This projection would be manageable if distances varied gradually. In Virgo, they do not. Nearby stars, distant galaxies, clusters, and superclusters are stacked along the same lines of sight. The flattening compresses this entire hierarchy into a single visual unit. The result is a patch of sky that looks modest but represents a vast corridor through space. You cannot undo this flattening by looking harder. No amount of visual attention reveals depth. The information is not present to be extracted. Depth must be supplied from elsewhere, reconstructed indirectly through parallax, redshift, and motion. Without these tools, Virgo remains two-dimensional, regardless of what it contains. This creates a systematic mismatch between perception and structure. You are shown only angles, while the universe is organized by volumes. Virgo's apparent boundaries are angular, but its physical contents extend far beyond those boundaries in depth. The sky encourages you to think laterally when the reality is longitudinal. The flattening also erases scale. Relationships. A star cluster and a supercluster can occupy the same visual footprint. Their true sizes differ by orders of magnitude, but those differences are invisible. The sky offers no metric for comparison. Everything is normalized to the same plane. This normalization has consequences for how you conceptualize size. When you ask how big Virgo is, you are tempted to answer in terms of area on the sky. That answer is technically correct and physically irrelevant. The structures that matter most in Virgo are defined by depth and mass, neither of which appear in that area. The flattening also stabilizes patterns that should not persist. The constellation's shape survives even as its contents change, move, and evolve. The stars drift. Galaxies fall into clusters, superclusters stretch, the projection holds them in place relative to one another, freezing a pattern that has no physical coherence. This is not unique to Virgo, but Virgo makes the effect explicit because of the range of scales involved. Few directions in the sky align so many layers of structure. The flattening becomes extreme. The sky compresses local and cosmic into the same frame without distinction. From this perspective, the sky is not a map of space. It is a map of directions. It tells you where to look, not what is there or how it is arranged. Virgo's apparent unity is a byproduct of this directional mapping. The unsettling implication is that most of the universe's structure is hidden behind this flattening. What you see is not a cross-section of reality, but a projection that discards critical information. The largest structures in the universe can be visually minimized to the point of invisibility. Even when you know this, the effect does not diminish. You cannot unsee the flattening. You continue to experience Virgo as a single patch, even as you learn that it contains a sequence of structures layered across deep time and space. The sky does not adapt to your understanding. It continues to present everything at once, without hierarchy or warning. Virgo remains small in appearance and vast in fact, unified in projection and fragmented in reality. This is the condition under which all astronomical questions of size must be asked. You are not observing from outside the universe, where depth could be seen. You are embedded within it, collapsing its dimensions by the act of looking. Virgo is not flattened because it is simple. It is flattened because you are here. Boundaries that do not exist. Constellations have borders drawn by convention. These borders feel precise, but no physical process respects them. The Virgo supercluster ignores the outline of Virgo entirely. Matter flows across constellation lines without resistance or acknowledgement. The borders of Virgo are defined by coordinate systems, not by space itself. They exist to organize observation, to prevent ambiguity when assigning objects to regions of the sky. On star charts, these lines appear clean and authoritative. They suggest enclosure. Measurement shows they enclose nothing. In physical space, there is no discontinuity where Virgo ends and another constellation begins. Stars cross these borders through proper motion. Galaxies drift across them as cosmic expansion proceeds. The boundaries remain fixed only because they are anchored to your viewpoint, not to the universe. This distinction matters when you consider structures like the Virgo supercluster. Its extent is determined by density gradients and velocity flows. These features do not align with the sky's divisions. The supercluster stretches across multiple constellations, intersecting and ignoring their borders entirely. Its shape is governed by gravity, not geometry on a sphere. The same galaxy can belong physically to the Virgo supercluster while appearing in a neighboring constellation. Conversely, many objects labeled Virgo have no physical connection to the supercluster at all. The boundary sorts by appearance, not by association. This creates a tension between classification and reality. The map you use to name the sky does not match the structure you are trying to describe. Virgo's borders remain stable, while the structures they are meant to reference are fluid and overlapping. This mismatch is usually invisible because the borders serve their purpose. They allow consistent communication. They let astronomers say where to look. But when you ask about size, the convenience becomes a liability. You are tempted to treat the borders as edges, as if they marked the limits of something real. They do not. The Virgo supercluster fades gradually into surrounding filaments and voids. There is no line where its influence stops. The boundary is statistical, not spatial. You can define it in several ways, none of which correspond to the constellation's outline. The effect is that Virgo has both too many edges and none at all. Visually, it is sharply bounded. Physically, it is diffuse. The sharper the drawn line, the less it reflects the underlying structure. This has implications for how you think about containment. If Virgo has borders, you expect what lies inside them to be related. Observation contradicts this. Objects inside share direction, not origin. Objects outside may share dynamics with what lies within. This reversal undermines the idea that size can be assigned cleanly. If you measure Virgo by its borders, you include unrelated foreground stars and exclude physically connected background galaxies. If you measure it by physical structure, you must ignore the borders entirely. The universe does not offer a compromise. It does not align its structures to your coordinate systems. Filaments cross the sky at arbitrary angles. Clusters span multiple labeled regions. The cosmic web cuts through constellations without distortion. This forces you to confront the provisional nature of all sky-based boundaries. They are tools, not truths. They describe how you see, not how things are. Virgo's borders tell you nothing about where matter concentrates or how it moves. The unsettling implication is that many questions you ask about the universe inherit assumptions from these boundaries without noticing. When you ask how big Virgo is, you assume it has an edge. In physical terms, it does not. What exists instead are gradients. Density decreases. Influence weakens. Connectivity changes. None of these transitions align with the lines on your maps. They are smooth, extended, and indifferent to naming. Virgo, in this sense, is a region without walls. It blends into neighboring structures seamlessly. The borders you see are artifacts of perspective and convention. They impose order where none exists, naturally. Understanding this does not make the borders disappear. You continue to use them, but they lose authority. They become reminders that your divisions of the sky are conveniences layered over a universe that does not recognize them. The size of Virgo cannot be confined by lines drawn on a chart. Those lines are stable. The structures they attempt to contain are not. Depth you cannot intuit. You can estimate width by eye. You cannot estimate depth. Virgo exploits this limitation. Its apparent size on the sky tells you almost nothing about how far it extends away from you. Measurement replaces intuition, and the replacement is not comforting. In everyday life, depth is inferred from familiar cues. Objects grow smaller with distance. Overlapping forms reveal what is in front. Motion parallax gives shape to space as you move. None of these cues function at astronomical scales. The sky removes them all, leaving you with angles and brightness, neither of which reliably encode distance. Brightness feels like a substitute for depth, but it fails quickly. A nearby dim star can appear fainter than a distant luminous galaxy. Without knowing intrinsic power, brightness misleads. Virgo contains objects whose luminosities differ by factors of billions. Your eyes cannot sort them by distance using appearance alone. This is why Virgo appears shallow. The constellation spans a modest region of sky. You instinctively imagine it as a thin slice of space. Measurement reveals that this slice is a corridor extending tens and then hundreds of millions of light years. The width remains fixed. The depth grows without visual signal. When distance measurements are introduced, intuition does not adapt. You learn numbers, not sensations. 60 million light years does not feel 60 million times farther than 1 light year. It feels abstract. The scale remains uninhabitable by imagination. This creates a gap between knowledge and perception. You know Virgo is deep, but you continue to see it as flat. The mind cannot reconcile the two without strain. The result is a quiet instability in how you think about space. This instability is not resolved by expertise. Even professional astronomers experience it. Data tables and models convey depth precisely, but the sky remains unchanged. The perceptual system that evolved to navigate meters and kilometers cannot scale to millions of light years. Virgo becomes a test case for this failure. It invites you to assign size based on appearance, then invalidates that assignment with measurement. The deeper you look, the less your original intuition applies. This has consequences for how you interpret structures. You might assume that two galaxies close together on the sky are interacting. Often, they are not. They may be separated by vast distances along the line of sight. Virgo contains countless such apparent pairings, visually convincing and physically meaningless. Depth also complicates causality. Objects that appear adjacent may be separated by millions of years in light travel time. You observe them together, but they do not coexist in the same moment. Virgo collapses temporal depth as well as spatial depth, stacking different epochs into a single view. This stacking is unavoidable. Light does not carry timestamps you can see. Without measurement, you cannot tell whether an object is near and recent or distant and ancient. The sky offers no warning that you are mixing time scales. Measurement corrects this, but only numerically. You are told how far away something is, not how it should feel. The correction does not restore intuition. It replaces it with abstraction. As Virgo grows deeper in your understanding, it becomes harder to summarize. You cannot say how big it is without specifying which depth you mean. Foreground stars define one scale. Clusters define another. Superclusters define another still. All occupy the same apparent space. This multiplicity resists simplification. Any single number hides more than it reveals. The question of size becomes conditional, dependent on thresholds and definitions. The unsettling implication is that much of the universe's structure lies in dimensions you cannot directly apprehend. You navigate a cosmos that withholds its depth from perception. Virgo is not exceptional in this regard, but it makes the limitation explicit. You are left relying on measurements you cannot internalize. They tell you that Virgo extends far beyond what you see, but they do not give you a way to experience that extension. The universe remains larger than your intuition can reach. In Virgo, depth dominates. Width misleads. Appearance reassures. Measurement unsettles. The constellation teaches you this without altering how it looks, leaving you to reconcile what you see with what you now know, without the help of perception. Light travel. Time overlap. Light from different parts of Virgo arrives simultaneously, despite being emitted millions of years apart. You observe multiple cosmic epochs at once. The constellation becomes a temporal stack as much as a spatial one. When you look toward Virgo, the photons reaching your eyes did not leave their sources together. Nearby stars emit light that takes decades or centuries to arrive. Galaxies in the Virgo cluster send light that has been traveling for tens of millions of years. More distant structures contribute light that began its journey before familiar features of Earth existed at all. Yet all of it arrives now, blended into a single moment of perception. This simultaneity is misleading. It suggests a shared present that does not exist. The sky presents everything as if it were happening at once, even though the events you are witnessing are separated by vast intervals of time. Virgo contains no single now. It is a collage of different pasts arranged by direction rather than chronology. In everyday experience, light travel time is negligible. You assume that what you see is what is happening. That assumption fails completely at cosmic distances. Virgo exploits this failure by aligning objects whose emitted light spans a wide range of ages. Your perception treats them as contemporaries. Physics insists they are not. This temporal compression alters how you think about structure. The Virgo cluster you observe is not the cluster as it is, but as it was. Its galaxies have moved since the light you see was emitted. Some interactions you infer from images may no longer be ongoing. Some configurations have already changed beyond recognition. Foreground stars complicate this further. They are seen almost in real time compared to the galaxies behind them. Their light is young. Their positions are current. They share the same frame with objects whose light predates human civilization. Virgo mixes these times without distinction. This mixture is not marked visually. There is no color shift that signals age in an intuitive way. The sky does not separate the recent from the ancient. Everything appears equally present. Only calculation reveals the temporal distances involved. As a result, Virgo is not just deep in space. It is deep in time. When you assign size to it, you are also assigning duration. The farther back you look, the larger Virgo becomes. Not spatially, but historically. It contains a record of different eras layered along the same line of sight. This layering introduces another instability. If Virgo contains multiple epochs, then its structures are not static. The cluster you define today is an average over time. The supercluster's shape evolves slowly but continuously. What you call Virgo is a time-smeared representation of something that never existed in that exact form. This does not invalidate observation. It defines its limits. You are not observing a snapshot. You are observing an accumulation. The image you form is assembled from light emitted under different conditions, influenced by different surroundings, and subject to different cosmic parameters. The implication is that causality becomes harder to trace. You may see two galaxies close together and assume interaction. In reality, the light from one may represent a much earlier stage than the light from the other. Their apparent proximity in time is an illusion created by travel delays. Virgo contains countless such coincidences, apparent alignments that never coexisted, apparent structures assembled from components that were never synchronized. The constellation becomes a diagram that ignores sequence. This challenges the idea that size can be defined independently of time. A structure extending millions of light years also extends millions of years into the past. Its spatial boundaries are inseparable from temporal ones. To ask how big Virgo is without asking when it is observed is incomplete. The unsettling part is that you cannot choose to see Virgo differently. You cannot isolate a single epoch. You cannot filter the sky by emission time. You receive everything together, compressed into a moment. Your perception calls the present. Even with this knowledge, the experience does not change. Virgo still appears as a unified region. The temporal stack remains hidden behind familiarity. You are left knowing that what you see never existed as a single state of the universe. Virgo, in this sense, is not an object, but a cross-section through time. Its size includes not just how far it extends in space, but how far back it reaches into history. You stand at the receiving end of this accumulation, observing a structure that is spatially dispersed, temporally fragmented, and presented as if it were whole. The constellation does not tell you this. Measurement does. And once you understand it, the question of Virgo's size becomes inseparable from the realization that you are never seeing the universe as it is, only as it was, layered, delayed, and combined into a single, misleading now the present that is not unified. When you look at Virgo, there is no single now. Nearby stars are seen almost as they are. Distant galaxies are seen as they were long before humans existed. The name Virgo labels incompatible moments as if they were one scene. This contradiction is built into observation itself. Light enforces delay, and delay fragments the present. What you call a view of Virgo is an assembly of signals that never shared a common moment. The sky offers coherence where none exists. It presents a unified image produced by fundamentally asynchronous events. In ordinary life, simultaneity feels reliable. You look around and assume that what you see is happening together. At cosmic scale, this assumption collapses. Virgo exposes the collapse quietly. Nothing about its appearance signals that the information reaching you spans tens of millions of years. The illusion of a shared present survives intact. The stars that define the constellation act as anchors for this illusion. Their light is comparatively recent. Their positions are stable on human timescales. They behave like objects in a familiar present. Behind them, the Virgo cluster unfolds in deep time, its galaxies frozen at stages they have long since passed through. You do not perceive the boundary between these regimes. There is no visible seam where the present gives way to the ancient. The transition is seamless because perception has no access to emission time. It registers direction and brightness, not history. As a result, the word now loses precision. Virgo cannot be assigned a temporal coordinate. Each object within it carries its own timestamp, set by distance. The farther away you look, the further back you are forced to observe. The present fractures into layers, but your awareness compresses them into one. This compression has consequences for interpretation. When astronomers describe the structure of the Virgo cluster, they are careful to specify that it is observed at a particular epoch. The cluster's true current state is unknowable without waiting millions of years. Any description is necessarily outdated the moment it is received. Foreground stars complicate this further by providing reference points that feel immediate. Their apparent coexistence with distant galaxies encourages the belief that all of Virgo belongs to the same temporal frame. It does not. The coexistence is a visual artifact produced by unequal light travel times. This artifact reshapes intuition. You may imagine Virgo as a stable region, populated by objects sharing a common cosmic era. In reality, it is more like a vertical slice through history, with each depth corresponding to a different age of the universe. The slice is thin in angle, but vast in time. The implication is unsettling because it undermines the idea of an observable present. There is no cosmic snapshot available to you. every observation is a reconstruction assembled from delayed signals. Virgo simply makes this reconstruction obvious by stacking radically different times into a single view. Even the concept of change becomes ambiguous. When you notice patterns or structures, you are not seeing them evolve. You are seeing outcomes of processes that have already concluded. The violence that shaped some Virgo galaxies is long over. The calm you infer may no longer exist. Yet the sky does not communicate this loss of immediacy. It remains serene, static, and apparently coherent. The knowledge that Virgo contains incompatible moments must be imposed intellectually. It is not delivered by sight. This gap between appearance and reality is not a flaw of astronomy. It is a condition of being embedded in the universe. You are constrained to receive information at the speed light allows. The present you experience is local, not universal. Virgo demonstrates that names are especially misleading. To label a region is to imply unity. To imply unity is to imply a shared state. Virgo has neither. It is unified only by convention and by the limitations of perception. Once this is understood, the sky becomes less like a window and more like an archive. Virgo is not showing you what is happening. It is showing you what happened, layered and unresolved. The present dissolves into a set of arrivals rather than a moment. You continue to look upward and experience a single scene. But that scene has never existed. Virgo is a reminder that the universe does not present itself as it is, only as it was, stitched together into a false now that your mind accepts, because it has no alternative. Gravitational centers. You cannot see. The Virgo cluster has a center of mass. The constellation does not. Yet both occupy the same region of your sky. One has physical cohesion. The other is a mnemonic. Observation forces both into the same visual category. This conflation happens automatically. Your visual system groups patterns by proximity and alignment, not by cause. When objects cluster on the sky, you interpret them as related. Virgo exploits this tendency. A gravitational structure and a historical drawing overlap, and perception treats them as comparable things. The distinction only appears when you measure forces instead of light. The Virgo cluster reveals itself through motion. Galaxies orbit a shared gravitational center that cannot be pointed to visually. There is no bright marker at the core. Its location is inferred from velocity dispersions, from the way galaxies accelerate toward an unseen focus. This center of mass is not symbolic. It is a physical consequence of matter concentration. Dark matter dominates it, outweighing stars and gas by orders of magnitude. Most of what defines the cluster's gravity does not emit light. The true center is therefore invisible by design, detectable only through its effects. The constellation Virgo offers nothing comparable. It has no mass distribution, no binding force, no center that could influence motion. Its stars do not orbit a shared point. They do not respond to each other gravitationally in any meaningful way. Their arrangement carries no physical information. Yet on the sky, both are assigned names, boundaries, and identities. The cluster inherits the constellation's label because it lies in the same direction. Language collapses the difference. A gravitational well and a visual outline are treated as related entities simply because they overlap in projection. This overlap creates a subtle error in intuition. You may imagine the Virgo cluster as sitting inside the Virgo constellation, as though one were nested within the other. In reality, only the line of sight is shared. The cluster occupies a defined volume of space. The constellation occupies none. The idea of a center is crucial here. A center of mass defines behavior. It dictates orbits, mergers, and long-term evolution. The Virgo cluster's center shapes the future trajectories of its galaxies. It is a reference point in space-time. The constellation offers no such anchor, because you cannot see the cluster's center directly. It feels abstract. Because you can see the constellation's outline, it feels concrete. This reverses their true status. The invisible structure is physically real. The visible one is an aid to memory. Astronomy often relies on this reversal. You see light, but infer mass. You see arrangement, but infer cause. Virgo makes this inversion explicit by aligning something meaningful with something arbitrary. The sky does not distinguish between them for you. Even maps reinforce the confusion. Star charts mark the constellation with clean borders and labeled figures. Galaxy maps show the cluster as a diffuse cloud with no sharp edge and no obvious core. The physically real object appears less defined than the fictional one. The reason is methodological. Boundaries in gravitational systems are statistical. They fade rather than terminate. A cluster's influence weakens gradually with distance. There is no precise radius where it stops existing. Any center you define is probabilistic, not absolute. Constellations, by contrast, are bounded by agreement. Their edges are crisp because they are imposed. This sharpness is comforting. It suggests control and clarity. The Virgo cluster offers neither. Its center is a region, not a point. Its extent depends on thresholds chosen by observers. When both are placed in the same visual frame, your brain defaults to the simpler interpretation. You remember the shape. You forget the gravity. The sky becomes a diagram rather than a system. Virgo, therefore, contains two centers of reference that cannot be reconciled. One is a fiction that organizes memory. The other is a reality that organizes matter. They coincide in direction, but diverge in meaning. Observation does not privilege the correct one. It delivers photons without explanation. To distinguish between the mnemonic and the physical, you must step outside perception and rely on inference. The universe does not signal which structures matter. Virgo reminds you that what holds things together is often invisible, and what you can trace easily may hold nothing at all. Expansion and distortion. Cosmic expansion stretches space unevenly across Virgo's depth. Objects farther away recede faster. This means Virgo is not only large, but internally distorted by time-dependent geometry. Its parts are not merely separated, they are separating. This effect is not abstract. It is measured directly through redshift. Light from more distant Virgo galaxies is stretched by the expansion of space itself. The greater the distance, the greater the stretch. Direction remains fixed, but scale does not. The region labeled Virgo contains objects that obey different expansion rates simultaneously. From your position, this produces a subtle inconsistency. Virgo appears as a stable patch of sky. Its outline does not swell or tear. Yet within that fixed angular region, space is undergoing differential change. The farther components of Virgo are being carried away faster than the nearer ones, even as they remain visually aligned. This is not motion through space in the ordinary sense. The galaxies are not racing outward from a central explosion. The space between them is increasing. This distinction matters because it breaks intuitive geometry. Distance becomes a function of time as well as position. Within the Virgo cluster itself, gravity partially counteracts expansion. Galaxies are bound together and resist being pulled apart. Beyond the cluster, expansion dominates. The transition between these regimes occurs within the same apparent constellation. Virgo contains both bound and unbound structures along a single line of sight. You cannot see where this transition happens. There is no visual cue that marks the point where gravity yields to expansion. The sky remains continuous. Only redshift measurements reveal that some Virgo galaxies participate in the Hubble flow, while others do not. This creates a layered geometry. Parts of Virgo are dynamically connected. Other parts are receding irreversibly. The constellation's apparent unity hides a boundary defined not by location, but by competing physical processes. Time intensifies this distortion. The farther you look, the earlier the light was emitted. You are observing expansion at different stages of the universe's history within the same frame. Virgo becomes a record of how expansion itself evolves with time. This has implications for size. When you ask how big Virgo is, the answer depends on when you measure it. Its distant components were closer together when the light you see was emitted. Their current separations are larger than what observation suggests. Virgo's true extent is therefore underrepresented in the sky. The distortion is asymmetric. Foreground stars are unaffected by cosmic expansion at all. Nearby galaxies drift slowly. Distant ones accelerate away. Virgo compresses these regimes into a single angular span, flattening a gradient of expansion into a uniform image. This flattening misleads scale estimation. You may imagine Virgo as a fixed volume. In reality, its components do not share a common metric. There is no single distance scale that applies across its depth. Each layer follows a different relationship between distance and recession. The result is that Virgo cannot be assigned a stable geometry. It is not a rigid object. It is a slice through expanding space sampled at multiple times. Any attempt to draw its boundaries ignores this internal deformation. Even the Virgo cluster, which resists expansion locally, is not immune indefinitely. Over cosmic timescales, its outskirts will be stripped away. Galaxies at its edge may eventually escape. The cluster's size is time-dependent, not absolute. This introduces a final complication. Expansion does not merely separate objects, it alters causal relationships. Distant Virgo galaxies are moving toward a horizon beyond which they will never be observed again. Their future light will never reach you. Virgo therefore contains objects that are permanently accessible and objects that are already lost in principle. They coexist in your sky despite occupying fundamentally different causal domains. The constellation offers no warning of this division. All components appear equally present. Expansion operates silently, reshaping distances and futures without visual disruption. When you look at Virgo, you are not seeing a static arrangement stretched across space. You are seeing a dynamically evolving cross-section of the universe, distorted by expansion, layered in time, and unified only by the limitations of observation. Measurement defines existence. Without distance, measurements Virgo would remain a flat picture. Parallax, redshift, and velocity dispersion create its depth. The size of Virgo is not something you see. It is something constructed from data. This construction follows strict rules. Each measurement technique applies to a limited range of distances. Parallax works only for nearby stars, where Earth's orbit provides a measurable baseline. Beyond that range, parallax collapses into noise. The nearest components of Virgo are therefore mapped with geometric certainty, while everything beyond requires different tools. Redshift replaces geometry at larger scales. It translates spectral displacement into distance through models of cosmic expansion. This translation is indirect. It depends on assumptions about the universe's overall behavior. The farther into Virgo you probe, the more interpretation is embedded in the measurement. Velocity dispersion adds another layer. Within the Virgo cluster, distances are inferred by analyzing how fast galaxies move relative to one another. Their random motions reveal the depth of the gravitational well they occupy. From this, mass and scale are inferred, not observed. Each method constructs a piece of Virgo under different rules. There is no single measurement that spans the entire structure. The region you call Virgo exists only after these incompatible techniques are combined into a unified framework. This means Virgo's size is conditional. Change the model of expansion, and redshift distances shift. Revise the mass estimate of dark matter, and the inferred extent of the cluster changes. Virgo's boundaries move without anything in the sky changing at all. The stars do not rearrange themselves when measurements improve. The galaxies do not spread out. Only your reconstruction changes. Virgo grows or shrinks on paper, not in light. This dependence on method reveals something fundamental. Existence at cosmic scale is not purely observational. It is mediated by theory. To say that Virgo has a certain size is to commit to a specific interpretation of data. This does not make Virgo imaginary. It makes it inaccessible without inference. The structure is real, but your access to it is abstract. You never encounter Virgo directly. You encounter numbers, spectra, and statistical correlations. The process resembles tomography more than photography. You assemble a three-dimensional object from multiple projections, each incomplete on its own. The result feels solid, but it is always provisional. Foreground stars complicate this further by providing direct distance anchors. Their well-measured positions create confidence. That confidence bleeds into regions where measurement is less direct. Virgo appears equally well defined across its depth, even though it is not. This uneven certainty is invisible to intuition. The sky does not communicate error bars. It does not distinguish between geometric measurement and model-dependent inference. Everything appears as equally present. As a result, Virgo's size feels like a property of the sky, rather than a conclusion drawn from analysis. This feeling is misleading. Remove the data, and Virgo collapses back into a pattern with no depth. The implication extends beyond this single constellation. Large-scale structures across the universe exist for you only insofar as they can be measured. Where measurement fails, structure dissolves into ambiguity. This does not mean the universe stops existing where measurement ends. It means your description of it does. Virgo marks a boundary between what can be directly known and what must be inferred. Even within well-measured regions, uncertainty persists. Distance ladders rely on calibration. Each rung depends on the previous one. Errors propagate outward, stretching or compressing Virgo in subtle ways. Despite this, the final image is often presented as settled. Maps show Virgo with apparent solidity. The underlying construction is hidden. The viewer is invited to accept size as a given rather than a result. Virgo resists this simplification. Its apparent coherence masks the fact that it only emerges when disparate measurements are reconciled. It exists as a synthesis, not as an object. When you ask how big Virgo is, you are really asking how far your measurement techniques can reach, and how consistently they can be combined. The answer is not written in the stars. It is assembled cautiously from the limits of observation. The question of containment. If Virgo contains stars, clusters, and superclusters at once, the word contain loses meaning. The constellation does not enclose matter. It aligns your perspective with it. Size becomes a function of viewpoint, not substance. Containment implies boundaries. It suggests that something exists inside something else, separated from what lies beyond. Virgo violates this implication at every level. Its stars are not inside a volume. Its galaxies are not enclosed by its outline. Its larger structures ignore it entirely. What remains is alignment without enclosure. This misalignment between language and reality is not accidental. Human spatial reasoning evolved in environments where containment was physical and reliable. A room has walls. A container has edges. These assumptions fail when applied to the sky. Virgo exposes the failure by appearing bounded while lacking any physical boundary. Astronomical maps reinforce the illusion. The constellation is drawn as a region with edges, and objects are said to lie within it. This phrasing is convenient. It is also inaccurate. The objects do not occupy a shared space. They merely fall along similar directions from your position. Direction substitutes for volume. From Earth, Virgo is defined by angles, not distances. Any object whose light arrives from that angular region is assigned to the constellation, regardless of how far away it is. Containment collapses into coincidence of viewpoint. This collapse has consequences for how size is interpreted. When you ask how large Virgo is, you may imagine a region expanding outward from the stars that define it. In reality, there is no expansion to track. The apparent increase in size comes from adding deeper layers along the same line of sight. Virgo grows not by spreading outward, but by extending inward and outward along depth you cannot see. Its size increases without altering its outline. This violates everyday geometry. Objects do not usually grow without changing shape. The contradiction persists because containment has been replaced by projection. Virgo is not a container. It is a column extending away from you with no defined end. Its apparent limits are set by convention, not by matter. This becomes more pronounced as you include larger structures. The Virgo cluster occupies a finite volume. The Virgo supercluster occupies a much larger one. Neither fits inside the constellation in any physical sense. Both intersect the same viewing direction. The word contain fails to describe this relationship. Even gravitational influence does not align with the constellation's borders. The forces shaping Virgo's galaxies extend across multiple constellations. Matter flows along filaments that cross arbitrary sky divisions without interruption. Containment dissolves under dynamics. What remains is perspective. From your location, Virgo gathers unrelated scales into a single category. The category persists because it is useful, not because it corresponds to structure. It organizes observation, not matter. This reframes size entirely. Virgo's size is not an intrinsic property waiting to be discovered. It is a question of how far along a given direction you choose to measure. Extend your instruments, and Virgo expands. Improve your sensitivity, and it expands again. There is no natural stopping point. Stars give way to galaxies. Galaxies give way to clusters. Clusters give way to larger patterns. At no stage does Virgo declare itself complete. Its apparent containment is endlessly violated by deeper observation. This suggests that size, in this context, is relational, rather than absolute. Virgo is large because your perspective intersects many structures along a narrow angle. Change your position, and the alignment changes. The constellation itself dissolves. If you were located elsewhere in the universe, Virgo would not exist. The stars would scatter into unrelated directions. The cluster would occupy a different patch of sky. Containment would be reassigned. This dependence on viewpoint is unsettling because it undermines objecthood. Virgo feels like a thing. It is not. It is a perspective artifact stabilized by tradition and reinforced by habit. The universe does not recognize Virgo as a region. It does not respond to its boundaries. Only observers do. The question of how big Virgo is, therefore, cannot be answered without specifying where you are standing. Virgo demonstrates that containment in astronomy is often linguistic rather than physical. What appears to hold things together may only be holding your gaze in place. Human patterning as a constraint. The name Virgo persists because human cognition prefers shapes over distributions. This preference survives even after measurements contradict it. The constellation remains stable while its contents expand outward in scale. This stability is not imposed by the sky. It is imposed by the observer. Your visual system is optimized to recognize outlines, edges, and figures against backgrounds. It is not optimized to interpret probability fields, depth gradients, or statistical structures. Virgo endures because it satisfies this preference cleanly. Once a shape is learned, it becomes resistant to revision. The stars of Virgo form a recognizable pattern, and that pattern anchors everything else that appears in the same direction. New information is absorbed into the existing frame rather than replacing it. Galaxies and clusters are added conceptually without disturbing the outline. Measurement does not erase the pattern. It accumulates beneath it. Even after learning that Virgo contains objects separated by millions of light years, you still see a single figure. The brain does not dissolve the shape into response to depth. It overlays depth onto the shape instead. This reveals a constraint on understanding. Human cognition treats shape as primary and scale as secondary. You grasp configuration before magnitude. Virgo exploits this ordering. Its outline is easy to retain. Its scale is not. Astronomical catalogs reflect this bias. Objects are indexed by constellation names long after the constellations have lost physical relevance. Virgo becomes a filing system rather than a structure. The name persists because it is cognitively efficient, not because it is accurate. This efficiency has a cost. By grouping unrelated objects under a single label. You flatten meaningful differences. A nearby star and a distant galaxy cluster share nothing physically, yet they are spoken of in the same breath because they share a projected location. The pattern overrides the distribution. The persistence of Virgo illustrates how human frameworks lag behind measurement. Data expands reality outward, but language and imagery remain fixed. The result is a growing mismatch between what is known and how it is mentally organized. You can see this mismatch in how scale is discussed. Virgo is often described as if it were a region with layers, as though adding depth preserves unity. In reality, adding depth destroys unity. The objects do not form a nested hierarchy. They merely align. Yet the pattern remains intact because abandoning it would require replacing shape with abstraction. Distributions are harder to visualize. They do not offer clean boundaries or memorable forms. Virgo survives because it is easier to remember than a three-dimensional probability cloud. This preference shapes not only constellations, but entire cosmological models. Large-scale structures are often described as filaments, walls, and voids because these metaphors preserve shape. They give form to distributions that are otherwise statistical. The language stabilizes understanding at the cost of precision. Virgo sits at the intersection of this tension. It is a named shape that contains increasingly shape-resistant information. Each new layer of measurement stretches the name beyond its usefulness. Yet the name does not disappear. The constellation's outline becomes a cognitive anchor point. It allows you to say where you are looking without saying what you are looking at. This convenience ensures its survival, even as its descriptive power erodes. The contradiction deepens as scale increases. At stellar distances, Virgo's pattern is already misleading. At galactic scales, it becomes arbitrary. At supercluster scales, it is actively deceptive. Yet it continues to frame discussion. This reveals a limitation that is not technological, but psychological. Instruments can resolve depth, motion, and mass. Cognition still defaults to two-dimensional grouping. The sky you understand lags behind the universe you measure. Virgo demonstrates that knowledge does not automatically rewire perception. You can know that the constellation is not a thing and still see it as one. The pattern asserts itself without asking permission. This persistence matters because it shapes intuition. Intuition influences the questions you ask and the answers you find plausible. A stable shape suggests a stable object. Virgo is neither. The constellation remains fixed because your pattern recognition system is conservative. It resists dissolution. Distributions feel incomplete. Shapes feel finished. Virgo endures not as a reflection of cosmic structure, but as a reflection of how the human mind constrains what it can comfortably hold. Comparing Virgo to the Milky Way. The Milky Way spans about 100,000 light years. The Virgo supercluster spans over 1,000 times that. Both appear in the same night sky. Your visual field offers no hierarchy between them. This equivalence is not subtle. The band of the Milky Way cuts across the sky as a continuous structure, dense with stars. Virgo occupies a quieter region, defined by sparse points of light. Nothing about this contrast communicates relative size. Brightness and texture mislead. The smaller structure dominates visually. Your perception assigns importance based on luminosity and continuity. The Milky Way overwhelms the eye because you are inside it. Its stars surround you. Their light is close and abundant. The Virgo supercluster, despite its enormity, contributes almost nothing to naked eye. Brightness. This inversion creates a false scale ordering. The structure you inhabit feels larger than the structure that dwarfs it. Virgo's galaxies are individually faint and distant. Their collective mass does not translate into visual dominance. Scale decouples from appearance. Measurement restores the hierarchy. Distances, velocities, and mass estimates reveal that the Milky Way is a minor component embedded within a vast network of galaxies. Virgo's supercluster scale structure defines the gravitational context in which your galaxy moves. Yet this context is not visible. You do not see the Milky Way as a small element of something larger. You see it as the largest thing in the sky. Virgo does not announce its dominance. It hides behind sparsity. This concealment is structural. The Milky Way is a disk observed from within. Its stars form a continuous plane across your field of view. Virgo is a three-dimensional distribution sampled from a distance. Its components do not fill space uniformly. They occupy nodes and filaments. As a result, the Milky Way communicates extent through density. Virgo communicates extent through absence. Most of its volume contains little luminous matter. Its size is defined by separation, not by filling. Your eye is poorly suited to this. It expects large things to be visually expansive. Virgo violates this expectation. Its scale exists primarily in the distances between objects, not in their visual spread. The comparison exposes a deeper issue. You are embedded in the Milky weighs structure, so its geometry is immediate. You are external to Virgo's large-scale form, so its geometry must be inferred. Presence substitutes for size. Even scientific imagery reinforces the imbalance. Photographs of the Milky Way are rich and detailed. Maps of the Virgo supercluster are abstract, composed of points and lines. One feels tangible, the other feels schematic. This affects intuition. You may accept intellectually that Virgo is vastly larger, but this acceptance does not translate into spatial understanding. The mind continues to rank the Milky Way as dominant because it is perceptually complete. Virgo's dominance is dynamic, not visual. The local group of galaxies moves relative to the cosmic microwave background in a way that reflects the gravitational pull of nearby large-scale structures, including Virgo. Motion reveals what sight conceals. Even here, the evidence is indirect. You infer Virgo's influence by subtracting known motions and examining residuals. The supercluster reveals itself through imbalance, not presence. The coexistence of these two structures in the same sky demonstrates the failure of visual hierarchy. The night sky does not scale itself for comprehension. It presents all structures at once, stripped of context. This flattening places incompatible magnitudes side by side. A structure you could cross in 100,000 years, and one that spans hundreds of millions of years occupy the same perceptual space. The difference must be learned, not seen. Virgo, therefore, undermines the idea that looking is a reliable way to understand size. The largest structures in the universe can be visually insignificant. The most visually dominant can be cosmically minor. When you compare Virgo to the Milky Way, you confront a universe that refuses to rank itself for you. Scale exists, but it is not encoded in appearance. It is hidden in measurement, waiting to contradict what your eyes insist upon: distance without separation. Two galaxies in Virgo may never interact, never influence one another, and never share history. Yet they are grouped together observationally. Proximity in the sky replaces physical relationship. This replacement is subtle but consequential. In everyday experience, proximity implies connection. Objects near each other tend to interact. They exchange forces, signals, or matter. Virgo violates this expectation by placing unrelated systems side by side in your field of view, while keeping them causally isolated in space. Galaxies separated by tens of millions of light years can appear adjacent on the sky. Their apparent closeness suggests potential interaction, but measurement denies it. their gravitational influence on one another is negligible. Their histories unfolded independently. They are neighbors only in projection. This projection strips distance of its usual meaning. You see 2 points of light separated by a small angle and interpret them as part of a shared environment. In reality, the space between them may be vast enough to prevent any exchange, now or ever. Cosmic expansion reinforces this separation. Even if 2 Virgo galaxies lie along similar directions, expansion may be carrying them away from one another faster than gravity can compensate. Their separation increases with time, not decreases. Apparent grouping hides permanent divergence. From your perspective, this divergence is invisible. The galaxies remain fixed relative to each other on the sky. Their separation in depth leaves no trace in angle. The universe allows objects to appear close while becoming increasingly unreachable. This breaks the intuition that spatial grouping implies relational significance. Virgo's grouping is observational, not physical. It is imposed by your position rather than defined by interaction. Astronomical catalogs reflect this imposed grouping. Galaxies are listed under the same constellation heading, regardless of whether they occupy the same cluster, filament, or void. The label communicates direction, not relationship. This directional grouping becomes misleading when interpreted as structure. You may imagine Virgo as a region where galaxies share a common environment. In reality, many of its components occupy entirely different large-scale contexts. Some Virgo galaxies reside in dense cluster cores shaped by repeated interactions and mergers. Others lie in sparse regions where isolation dominates. They are assigned the same sky address despite living under different physical conditions. The difference matters because environment determines evolution. A galaxy's shape, star formation rate, and future trajectory depend on its surroundings. Virgo's observational grouping erases this information by flattening environments into a single category. This flattening affects how size is perceived. If objects grouped together are assumed to be related, then the region containing them is assumed to be coherent. Virgo appears as a large but unified structure. Measurement shows fragmentation instead. Distance without separation also distorts causality. You observe light from these galaxies simultaneously, and may assume simultaneity implies relevance. In fact, their observed coexistence carries no causal weight. It is an accident of alignment and light travel time. The universe does not privilege your line of sight. It does not organize itself to reflect relational truth in projection. Virgo is an example of how easily perspective can override physical meaning. Even gravitational lensing, which can reveal mass distributions along the line of sight, does not restore relational clarity. Multiple mass concentrations at different depths can lens background light independently while appearing to belong to a single region. The result is a layered sky where distance separates without revealing itself. Objects drift apart in reality while remaining visually adjacent. Separation becomes something you must calculate rather than observe. Virgo therefore teaches a negative lesson. What appears together need not belong together. What is grouped need not be connected. Spatial intuition fails when depth is inaccessible. This failure is not corrected by better images. Higher resolution sharpens points, but does not expose distance. Only measurement breaks the illusion. And even then, the illusion persists visually. When you look at Virgo, you see togetherness where none exists. The galaxies do not acknowledge one another. They do not share forces or futures. They merely share a direction from you. Distance without separation is the rule, not the exception at cosmic scale. Virgo makes the rule visible by refusing to align appearance with relationship. Virgo as a line of sight. At its most accurate, Virgo is not a place, but a direction. It is a vector extending from your position through nearby stars, past clusters, and into deep cosmic structure. Its size depends on how far along that vector you choose to measure. This reframing resolves several contradictions at once. A direction can contain unrelated objects without requiring coherence. It can intersect multiple structures without enclosing them. When Virgo is treated as a vector, its apparent contradictions become consequences of perspective rather than failures of classification. The vector begins locally. It passes through stars whose distances are measured in tens or hundreds of light years. These stars are embedded within the Milky Way's disk and share its rotation and history. They are the first points encountered along the line of sight. Beyond them, the vector exits the local stellar neighborhood and enters interstellar space that contains little luminous matter. This region contributes almost nothing to what you see, yet it occupies vast volume. The absence of markers does not imply absence of distance. Farther still, the vector intersects the Virgo cluster. Here, the density of galaxies increases. Gravitational binding becomes relevant. The vector now passes through a region where matter interacts strongly, shaping trajectories and histories. This interaction is local to the cluster and does not extend backward along the vector. Beyond the cluster, The vector continues through lower density regions, filaments, and voids that belong to the larger supercluster. These structures are not centered on Virgo in any physical sense. They are intersected by the same viewing direction due to your position in space. At no point does the vector encounter a boundary labeled Virgo. The label is applied after the fact, based on which stars were historically grouped together. The direction existed before the name. The name stabilizes the direction. This stabilization encourages the illusion of place. A place has extent and boundaries. A direction has neither. It can be extended indefinitely. Virgo's apparent growth with improved measurement reflects this. Each new survey pushes the effective end of the vector farther out. This makes size an arbitrary parameter. You can define Virgo as extending to the nearest stars, to the Virgo cluster, to the limits of the supercluster, or beyond. Each choice is defensible. None is privileged by physics. The universe does not segment itself into viewing directions. It does not provide natural stopping points along a line of sight. Any termination you impose is methodological, not physical. This undermines the idea that Virgo has a true size waiting to be discovered. Instead, it has a series of scales that can be accessed depending on how deeply you probe. Size becomes conditional on inquiry. The line of sight interpretation also clarifies why Virgo feels coherent despite its fragmentation. A vector is coherent by definition. All points along it share a direction. This shared property substitutes for physical relationship. Your brain readily accepts this substitution. Direction is easier to process than depth. The sky presents directions cleanly and distances ambiguously. Virgo aligns with what perception can reliably encode. Once this is recognized, the constellation's persistence becomes understandable. It is a stable coordinate in your sky. It allows you to orient yourself without requiring three-dimensional understanding. However, this orientation comes at a cost. Treating Virgo as a place encourages false inferences about containment, scale, and relationship. Treating it as a direction removes those inferences, but also strips away intuitive meaning. A direction cannot be inhabited. It cannot evolve. It cannot have internal structure. All such properties belong to the objects it intersects, not to the vector itself. Virgo, therefore, exists only at the interface between observation and interpretation. It is a product of where you stand and how you look, not of what the universe builds. When you look toward Virgo, you are not looking at a thing. You are sampling a cross-section of the universe, aligned by chance and tradition. The size of that cross-section expands only as far as your instruments and models allow. The question of how big Virgo is becomes inseparable from how you define looking. The absence of a natural end. There is no clear point where Virgo stops. Beyond the supercluster lie filaments and voids connected to larger cosmic networks. The constellation provides no rule for where relevance ends. This absence is not a gap in knowledge. It is a feature of large-scale structure. Matter in the universe arranges itself hierarchically, but without sharp boundaries. Density increases and decreases gradually. Structures overlap and interpenetrate. Virgo participates in this continuity without defining it. When you move outward from the Virgo cluster, the transition to the surrounding supercluster is statistical. Galaxy density thins, velocities change, correlations weaken. At no distance does the structure declare itself finished. Any boundary drawn is a choice made by the observer. Beyond the supercluster, filaments extend toward other concentrations of mass. These filaments are not neatly separated. They branch, merge, and fade. Virgo connects outward through these structures without interruption. Its influence dissolves rather than ends. From your perspective, this creates an unbounded extension along the Virgo line of sight. Each layer gives way to another. Measurement pushes outward, and relevance follows. There is no physical event that marks a stopping point. This challenges the notion that structures must be isolatable to be meaningful. Virgo does not exist as an island. It exists as a region of enhanced correlation within a continuous field. Its identity depends on thresholds you impose. Astronomers choose these thresholds for practical reasons. They define clusters by density contrasts, superclusters by coherence in motion, and filaments by elongated correlations. Change the threshold, and Virgo's extent changes. The sky does not signal which threshold is correct. The structures do not align with constellation boundaries or even with each other cleanly. Relevance becomes a sliding scale rather than a fixed property. This sliding scale undermines attempts to assign a definitive size. Any size you quote depends on how much of the connected network you choose to include. Virgo expands or contracts based on analytical preference. The problem intensifies because connectivity increases with scale. At the largest scales, the universe resembles a web. Individual structures lose distinct identity as connections proliferate. Virgo becomes a denser node within a mesh rather than a separable entity. This is not a failure of classification. It reflects the underlying physics of structure formation. Gravity amplifies small fluctuations, producing nested patterns without hard edges. Virgo inherits this ambiguity. Your intuition, however, expects completion. It looks for edges where one thing stops and another begins. Virgo denies this expectation. It offers continuation instead. This continuation is invisible to casual observation. The sky appears finite. Constellations carve it into manageable segments. But these segments do not correspond to how matter is organized. As you trace Virgo outward, relevance does not diminish abruptly. Galaxies farther away still contribute to the gravitational landscape. Their motions reflect connections beyond the cluster. Influence decays, but does not vanish. The lack of a natural end also affects causality. Distant structures connected through filaments may influence one another over long timescales. Virgo's future evolution is not determined solely by its immediate contents. This interconnectedness complicates prediction. You cannot isolate Virgo and simulate it in isolation without losing accuracy. Its environment matters indefinitely. Yet the constellation suggests isolation. Its outline implies separation from neighboring regions. This implication is false. The universe does not respect these divisions. Virgo's absence of an endpoint reveals a mismatch between human categorization and cosmic organization. The categories are finite. The structures are not. When you ask where Virgo ends, you are asking a question the universe does not answer. It offers gradients, not borders. It offers networks, not containers. The constellation remains silent on this. It continues to label a direction while offering no guidance on depth. The responsibility for defining relevance falls entirely on the observer. Virgo persists as a reminder that some questions have no natural resolution, not because of ignorance, but because the structure itself refuses to terminate. There is no clear point where Virgo stops. Beyond the supercluster lie filaments and voids connected to larger cosmic networks. The constellation provides no rule for where relevance ends. This absence is not a limitation of observation. It is a property of structure. Matter in the universe does not assemble into sealed regions. It aggregates hierarchically, with density tapering gradually rather than terminating. Virgo participates in this hierarchy without ever completing it. As you move outward from the Virgo cluster, the change is not categorical. Galaxy density declines. Correlations weaken. Motions become less coherent. But nothing breaks. The transition from cluster to supercluster is defined only by statistical thresholds chosen for convenience. These thresholds are adjustable. Change the density criterion, and the cluster grows or shrinks. Extend the velocity coherence requirement, and the supercluster expands outward. Virgo's extent responds to definitions rather than dictating them. Beyond the supercluster, filaments continue. These filaments do not radiate cleanly from a center. They weave through space, connecting concentrations of matter across hundreds of millions of light years. Virgo's mass participates in this network without occupying a privileged position. From your hostess's perspective, the Virgo line of sight intersects these structures sequentially. Each layer feels like an extension of the previous one, because there is no physical event that marks a boundary. Relevance does not end. It thins. This thinning challenges the idea that size should be finite. If relevance fades gradually, then any stopping point is arbitrary. Virgo has no natural edge because gravity does not produce them. The constellation's outline suggests a region you can step out of. In reality, stepping outward along that direction only reveals further connectivity. The universe offers continuation where you expect closure. This continuation has consequences for interpretation. If Virgo has no end, then its size cannot be stated as a single value. Any number you assign reflects how far your analysis extends before you decide to stop. This decision is influenced by instrumentation, models, and patience, rather than by cosmic structure. Virgo grows as surveys deepen. It contracts when focus narrows. Nothing intrinsic changes. The lack of an endpoint also undermines isolation. Virgo cannot be treated as an independent system beyond a limited scale. External structures influence its evolution through tidal forces and long-range gravitational fields. Its future is entangled with regions far beyond its apparent core. This entanglement is invisible. The sky does not indicate which distant structures matter and which do not. Influence arrives diluted over time, not marked by borders. The expectation of an end is psychological. You are accustomed to environments where objects are bounded. The universe is not built this way at large scales. Virgo exposes this mismatch by refusing to conclude. Even cosmological simulations reflect this. When Virgo-like structures are identified, they are embedded in larger volumes that must be simulated simultaneously. Cutting them out introduces errors. The context cannot be removed. This dependence on context erodes the idea of a self-contained object. Virgo is not a thing with edges. It is a region of elevated density within a continuous distribution. The constellation's silence on this matter is telling. It offers no guidance on depth or termination. It simply marks a direction and leaves everything else unresolved. When you ask how far Virgo goes, you are imposing a question shaped by terrestrial intuition. The universe responds with gradients and connections, not with answers. Virgo's lack of a natural end is not an omission. It is a lesson. It demonstrates that at cosmic scale, relevance does not stop. It fades, overlaps, and re-emerges elsewhere. The constellation remains fixed while the structures associated with it dissolve outward into the cosmic web. What persists is not Virgo itself, but the direction you continue to look. Measurement without closure. Each improvement in observation extends Virgo further. Larger surveys reveal larger structures. The question of size becomes recursive. The better you measure, the less final the answer becomes. This recursion is not a failure of precision. It is the predictable outcome of probing a universe without hard boundaries. Every observational advance widens the frame within which Virgo is interpreted. What once appeared complete becomes partial the moment resolution improves. Early observations confined Virgo to a pattern of stars. Telescopes extended it to nearby galaxies. Redshift surveys expanded it into a cluster. Wide field mapping absorbed it into a supercluster. Each step felt conclusive at the time. Each was later surpassed. The structure did not change. Only the reach of measurement did. Virgo's apparent growth is therefore not expansion in space, but expansion in description. The object inflates as the map improves. This creates an asymmetry between effort and result. Increased accuracy does not narrow uncertainty. It broadens context. You gain detail locally, but you lose finality globally. Virgo becomes better understood and less defined at the same time. This pattern repeats across cosmology. Improved instruments resolve smaller scales while simultaneously exposing larger ones. Boundaries dissolve faster than they are clarified. Virgo exemplifies this tension because it sits at the intersection of many scales. When surveys deepen, they do not simply add distant objects. They reveal connections. Filaments link clusters. Motions correlate across larger volumes. Structures once thought separate merge conceptually. Virgo absorbs its surroundings without changing its name. The recursive nature of size emerges from this absorption. Each new layer forces a re-evaluation of what should be included. Is relevance defined by density, by motion, by causal influence, or by historical association? Measurement answers some questions while raising others. No observational threshold delivers closure. There is no resolution at which Virgo declares itself complete. Higher sensitivity reveals fainter galaxies. Wider coverage reveals extended correlations. Improved modeling reinterprets existing data under new assumptions. Even null results extend Virgo. Discovering that a region lacks galaxies informs the shape of surrounding structures. Absence becomes data. The mapped volume grows. This undermines the expectation that knowledge converges toward a final description. In this context, knowledge expands outward. Precision sharpens Gemins locally, but destabilizes the whole. Virgo's size therefore resists summarization. Any numerical answer is provisional. It encodes the limits of current surveys rather than the limits of structure. This provisionality is often concealed in presentation. Maps display Virgo with apparent completeness. Legends do not show the frontier of uncertainty. The viewer is not told how much lies beyond the edge of the data. Yet astronomers are aware of this incompleteness. Survey volumes are chosen for practicality. Boundaries are drawn where data quality declines. These choices are methodological, not physical. As methods improve, the boundaries move. Virgo expands again. The act of measurement ensures that it will. This creates a subtle inversion. Instead of measurement converging on an object, the object recedes from measurement. Virgo becomes a moving target defined by the horizon of observation. The recursion is intellectual as well as observational. Each refined definition of Virgo exposes assumptions in the previous one. What counted as structure is reclassified as substructure. What counted as environment becomes structure. There is no privileged scale at which this process stops. Gravity operates across all of them. Correlation lengths increase with survey depth. Virgo's relevance leaks outward indefinitely. This does not imply that Virgo is meaningless. It implies that meaning is scale dependent. Virgo exists differently at different levels of analysis. No single level has priority. The discomfort arises from the absence of closure. You are accustomed to answers that settle questions. Virgo offers answers that reopen them. Improved clarity leads to expanded uncertainty. The constellation remains unchanged, while the structure associated with it grows increasingly indefinite. The name stays fixed. The content escapes. Measurement without closure is not an anomaly. It is the normal state of cosmology. Virgo simply makes it explicit by refusing to stop growing as you learn more about it. Each time you ask how big Virgo is, the answer reflects how far you have looked. not how far it goes. What the question assumes. To ask how big Virgo is assumes that it is one thing. Observation shows it is many unrelated things forced into one label by perspective. The size of Virgo is not a number. It is a conflict between how you see and what the universe measures. The question itself carries hidden commitments. It presumes coherence where none is guaranteed. It presumes boundaries where observation finds gradients. It presumes that a name corresponds to a physical object rather than a viewing convention. Before any measurement begins, the structure of the question has already narrowed what kinds of answers seem acceptable. When you ask for size, you imagine an edge. You imagine a region that can be circled, enclosed, or compared. But Virgo resists this framing. Its stars do not share origin. Its galaxies do not share destiny. Its clusters are not bound into a single system. What unites them is not physics, but alignment. The sky encourages this misunderstanding. Vision collapses depth. Light from unrelated distances arrives on the same retinal surface. The brain, evolved to interpret flat scenes, completes the pattern. Virgo emerges as a figure because cognition demands figures. Measurement intervenes and breaks the illusion, but only partially. Distances are added. Velocities are cataloged. Structures are classified. Yet the name remains. The question persists. Virgo survives the contradiction because language is slower to update than data. Asking how big Virgo is also assumes simultaneity. It assumes that all parts of Virgo exist in the same temporal frame. They do not. Some components are seen nearly in their present state. Others are seen as they were before complex life existed on Earth. The question ignores this temporal fragmentation. It also assumes relevance. Why group these objects at all? Why should a nearby star and a distant cluster be discussed together? The answer is historical, not scientific. They were grouped before their distances were known. The category endures because it is familiar. The universe does not recognize Virgo. There is no marker in space where properties change because the constellation begins. No gravitational threshold, no density transition, no causal boundary. The label floats above the data, imposed rather than discovered. This is not unique to Virgo. Many astronomical questions inherit assumptions from earlier observational regimes. Terms persist after their original meaning dissolves. The question becomes a fossil, preserved even as understanding moves on. When modern cosmology addresses Virgo, it does so selectively. Sometimes Virgo means a constellation. Sometimes it means a cluster. Sometimes it means a supercluster. The same word is stretched across incompatible scales. The ambiguity is tolerated because precision is supplied by context. But when the public asks how big Virgo is, context collapses again. The question tries to compress these meanings into a single answer. The result is confusion disguised as curiosity. Scientific answers often respond by choosing one interpretation silently. A number is given. Units are attached. The conflict is hidden. The question appears resolved, but only by narrowing its meaning without acknowledgement. Yet the more honest response is that the question cannot be stabilized. Virgo is not the kind of thing that has a size in the way objects do. It has extents at different scales, depending on which definition is activated. This reveals a deeper tension between observation and categorization. Observation fragments. Categories unify. Virgo sits at the fault line between them. It exposes how much of what you think you see is supplied by expectation. The discomfort you feel when the answer keeps changing is not confusion. It is recognition. You are noticing the mismatch between human concepts and cosmic structure. To ask how big Virgo is, then, is to ask the universe to honor a human boundary. The universe does not comply. It offers distributions, correlations, and continuities instead. The question assumes unity. The universe provides multiplicity. Virgo exists in the gap between them, not as a thing to be measured, but as a reminder of how measurement begins with assumptions you rarely examine.